Hi guys, I'm Michael and I've studied industrial electronics. In this course, we wanna learn how can we describe linear control systems in Matlab. Don't waste time, let's start it. In order to simplify the commands, the control system toolbox can also use data structures. There are three basic forms to describe LTI systems in Matlab. We can write SISO systems in three different forms. 1. Transfer function form. 2. Zero pole gain form. And 3. State space form. In this section, we'll learn how we can define transfer function form in Matlab. The transfer function of a system is represented by two arrays of numbers. Consider system 1 and system 2. These systems are represented as two arrays, each containing the coefficient of polynomial in decreasing power of s as follows. For system 1, we have here for numerator 2. We have to consider here in numerator 2s power 0, and for denominator we have 1s power 2, 3s plus 2s power 0, 1, 3, 2. And also for system 2, for numerator we have 1, 1. We have here in numerator 1s plus 1s power 0, and for denominator we have 1s power 2 plus 3s power 1 plus 3s power 0. We write here between bracket 1, 3, 3. Now we go to Matlab and define our two systems, system 1 and system 2 in Matlab. Okay, now we start to define our systems in command window. For system 1, we have to write first of all numerator of system 1. We have to write here 2 between brackets, and for denominator we have 1, 3, 2, semicolon. Right here system 1, transfer function, parentheses, numerator and denominator, enter, and we got our system 1. And for system 2 also, for numerator we have here 1, 1, semicolon. For denominator we have 1, 3, 3. We write here system 2 is equal transfer function, parentheses, numerator, denominator. Also we got our system 2. And there is another way for defining our systems in Matlab. We can define s as a string. For example, if we write s is equal transfer function s, and now we can write our systems normally. For example, for system 1 we have, or for system 2 for example we have ESP plus 1 division s power 2 plus 3s plus 3. Enter. As you see, we got the same result, and we can use both ways for defining our systems. We have also the same rules in MIMO systems. In MIMO systems, we have multiple inputs and outputs. Now we consider system H, which has 2 inputs and 2 outputs. It is included 4 separated transfer functions. The first one is H11, the second one H12, third one H21 and H22. It is important to know when we say Hij, that means our transfer function is from input j to output I. Now we go to Matlab and define our MIMO system. In MIMO systems, we have to define each transfer function separately. Now we have 4 transfer functions. That means we have to first of all define our H11 third transfer function, parentheses. Now I write here directly numerator of H11. We have 1, and for denominator we have 1, 1. Also for H12 equal transfer function numerator of H12 is 1, 1, and denominator 2, 1. For H21 we have transfer function parentheses 1 for denominator 2, 1, and for H22 also we have for numerator 1, 1, and for denominator we have 3, 1. Now for our systems, H is equal brackets right here H11 H12 semicolon. I go to the next line H21 and H22. Enter. As you see, we got 4 transfer functions from input 1 to output 1, from input 1 to output 2, from input 2 to output 1, and from input 2 to output 2. We can also define transfer function form in MIMO systems in another way. We have to define all numerators together and also all denominators together. Now we go to Matlab and define our H system. Now I define all numerators, I write here n is equal, please be careful, now we have to use braces, not brackets. For h11 I have 1, for h12 I have I go to the next line. For h21 I have 1, and for h22 I have 1, 1. And also for all denominators is equal, braces. For h11 I have 1, 1. For h12 I have 2, 1. Next line. For h21 I have 2, 1, and for h22 I have 3, 1. Now I write here for system h is equal transfer function parentheses numerator and denominator. Enter. As you see, we got the same results like last way. For h11, for h12, for h21, and for h22. Okay, in this part we have learned how we can define SISO systems and MIMO systems with transfer function form in Matlab. In the next video, we want to learn how we can define with zero pole gain form.